Today we're going to be talking about the expansion of product of algebraic terms, also known as the distributive property. First thing we're going to do though is start with a product of single terms, and that's when you have these two single terms stuck together, so you have pq squared times qr to the fourth. So that means we have p times q times q times q times r times r times r times r. So then when I combine all my terms, I see that I have p q to the third and r to the fourth. Really what I did was just set everything all out in one long string, and then I combined all my like terms together. Let's take a look at something now involving coefficients. Hello, where'd you go? Oh, there you went. So we have 2m to the second n times 7m to the third n. I'm going to go ahead and get started here. First I'm going to deal with my coefficients. So that means I have 2 times 7 times m times m. I like to put my coefficients in the front because it makes things easy. And then times, so I have those two m's, times m times m times m, m times m times m, times n times n. Alright, so that when I start to combine my like terms, I see that I have 2 times 7 is 14. Then I have m times m times m times m times m. So I have 5 m's being multiplied together. Remember, an exponent's telling me how many times that base is being multiplied together. And then I have 2 n's. So my answer ends up being 14 m to the fifth n to the second. So with single terms, you can see you just string it all out, line it up together, and you can get your answer. Now this isn't the most efficient way, and maybe you can start to see some shortcuts there. For example, if I were to give you something like AB times B squared C, you might be able to pretty swiftly give me that solution. Pause if you want. But what we want to do before I go ahead is think back to the distributive property that you talked about in school last year. And that's when you have something like a times x plus y. And so you remember with the distributive property, you're distributing that a into x and y. So you're multiplying everything inside the parentheses by a. So then your outcome ends up being ax plus ay. What we're going to do right now is take a look at a diagram that's going to help us once the problems start to get a little trickier. Here we have a product of two expressions. So you see I have a rectangle, and the side length of this rectangle is a plus b, and the side length over here is x plus y. So I'm looking for the product of a plus b times x plus y. So first thing I'm going to do is take a look at the first combination here. I have a times y, and that gets me the area of this rectangle, which is ay. Then I have, oh, I got to change that color. Then I have my next rectangle, a times x, and that gives me the area ax. Then I repeat it for the rest, so I have b times y. That gets me the area of this rectangle, which is by. And then the area of d is going to be b times x, so that's bx. So the area of the large rectangle is going to be the area of capital A plus capital B plus capital C plus capital D, because now we're looking at the entire rectangle, which means a plus b times x plus y is going to be ay plus ax plus by plus bx. Now, you can't always draw pictures to represent a product of two algebraic expressions. But what we can do is use the distributive property to come up with a solution. There's also another method that I'll show you as well. So let's take a look at y plus 1 times y plus 7. First thing I'm going to do is go ahead and use the distributive property. So that means I have y times y plus 7 plus 1 times y plus 7. I'm distributing both the y and the plus 1 into y plus 7. So everything's getting multiplied by everything else. And now I'm going to go ahead and use a distributive property. So y times y is y squared. Y times 7 is 7y. 1 times y is just y, or 1y. And 1 times 7 is 7. So now I'm left with y squared plus 7y plus y plus 7. If I combine my like terms, I get y squared plus 8y plus 7. I have expanded from factored form. Usually when you see this, this is known as factored form, to expanded form. I know my answer is complete because it is set up as a trinomial. So that was the first method, using the distributive property. The other method is to use long multiplication. So what I'm going to do is set it up as a multiplication problem. I have y plus 1 times y plus 7. So just like we used to do over here, and now, so we start out with 7. 7 times 1 is 7. 7 times y is 7y. I need to be careful here with my positives and negatives. Now I'm going to go skip a line over here. Let's see if we can put a little placeholder here, just like we used to do. You don't have to put that 0 in there. You can just pretend that it's there as a placeholder. And we'll go to the next section. So now I have y times 1. It's going to get me y. And then y times y. So that was a positive y. Y times y, we see they're both positive. That's y squared. So just like with long multiplication, now I bring everything down. I see 7 plus 0. That was my placeholder, is 7. It's a positive 7. 7y plus y is 8y. And then I bring down the y squared. So you see that whichever method I use, whether it's the distributive property or long multiplication, I end up with the same answer. You can use either to get your to find your solutions. So you're going to try this one out on your own, and I'm going to give you the solution tomorrow. You can use either the distributive property or the long multiplication method. You'll notice now though, there's already a trinomial, so that's going to make it a little trickier. My hint to you is just you need an extra step. And if you want to see what it looks like written out using long multiplication, it's going to look something like this. And the one thing that you're going to need to be careful of is to follow the positives and negatives. All right.